This new video will show you how to code a RF leg. First of all, what is a RF leg? A RF leg, like we have on this procedure, is a path terminator that goes from one fix to another fix, but radial to fix. There's a radius. Trajectory is with one center point about here in this example. So the trajectory will absolutely be on the line, on the radius. So it is mandatory to arrive on this radius by a leg that ends on the good course and ended at the good course also for the leg after. So many things are mandatory. Not all of them will be seen today, but we will see quite all of them. How to do it? It's easy with Arinc Decoder. I will start with one trajectory I already have, the one I just show you. This trajectory exists. This one exists with a radius to fix. We can see it here, a radius to fix around a point center arc point that its name is arc 1 Romeo for right turn. If I show it to you like that, okay, so we have a radius to fix from the point named Cocac to the point named Faf fix final 31 right at LFML, Marseille in France. So I'd like to do the same, but I'd like to make radial to fix also, but coming from left hand. On the other side, I have a star. I have a star coming on the point tunnel, but I have another star coming in the point here, something like about here, and I'd like to come on a line on the runway 31 right or the 31 left. Both are to do. I will show you the other star, left hand star. Okay, the point goofy here. I want to make a radius to fix coming from Bolmo goofy. Then we will go on left runway. So we will create the runway and we will create another FAF here on a radial to fix. First of all, we have to create the runway and the runway extension to the FAF, as we already know how to do. Hop. So I have to create a new procedure. The procedure name will be R31 left visual. Airport is LFM Lima. Approach, I get the basic data. Its name will be this. And here it is. Now I have to take the runway. So the runway is, first of all, 31 right, 30 right, and 31 left. So I take 13 right, then 31 left. For that, I have the distance and the heading 134.8 from the runway 31 left. So I take this point. I remember 134.8. 134.8. I put it at 3 nautical miles. We don't care. And this is the FAF. This is the position of the point we will call the FAF. Okay. Just to see that we are not completely out, I put the point here. So I will make a RF leg from goofy here to this point. but this point I have to insert it in my system. The point will be final FAF 31 left. The coordinates are just them that I just copy, and here's my point. I can save. My weapon terminal FAF 31 left is here. So from now I have the leg. Sorry, I will put that here. I have the leg from this runway to this runway to this point and to this point. Bolmo Gouvy, FAF 31 left on runway. The 4 points are necessary, mandatory to create a RF leg. So we take, I can remove this. I take back this data and I have here a button RF leg center. We need to give the position of our center leg. It's really easy. Take care of the way I do it. I can remove this screen, also this one, this to have the map. We are coming from Bolmo to Gouvy. Sorry, I have to put this back. Bolmo to Gouvy. I just take Bolmo, the point Bolmo, I take it here, and I import it on this screen. After that, it's Gouvy. I put it here, Gouvy. I import it here. After that, it is the FAF, just the last one we did. I import it in position 3, and after that, next will be the runway 31 left. Up. Here, I have to compute the position of the center of my turn. It's really easy. We know that we have a left turn, so we have to tell the system that we turn left, and I can push on the button compute. We have the position of our center, but we have the radius, we have the distance, but the precision is not enough. The precision is not enough. We can move one of the points to, I can show you why the precision is not enough. That because here, from this leg to this leg, I need a center here, and from this leg to this point to this point, the perpendicular means that the good center of the RF is here. So it's not the same center, so it's not possible. There's only, it's small, there's only 166 meters of error. But we can do better. Of course, we can move this point, this one, the runway. We cannot move the runway, and we cannot move the 2 other waypoints because they are officials. So we have to move something not official. Our FAF was completely, I put it at 3 nauticals from the threshold, so I absolutely can move it. I can move number 3, point number 3 here. I move number 3 underline 3 to 4. If I push on this button, I see that now I have 83. I move it also 42, 21, 11. Up, no more big error, and I do, and each time, and now I have only 21 centimeters. I cannot be better than that. So I can keep it. The only thing that changed is the point number 3. So now the FF31 left doesn't have the same coordinates. So I copy the data and I go on this module. I take the old point and I pass the new coordinates. I press on change and the data are now saved. Can push and save here. I got now only less than 1 centimeter of error. I can show the radius. So now we see that from the point here, the radial to fix the center is here. So the turn will turn around this city, name the row that we have not to overfly. We will see after the trajectory, of course. So now we have our center RF leg, the center. We have to copy its coordinate, it's here. And I go back, I just copy it, I go back and I create a new waypoint. The new waypoint will be center 2 because I already have one other center. Center 2, coordinates I passed. And OK, I got it. Can save. I'm happy. So from now, we can create our new procedure. The procedure we know that's going from Balmo. Balmo could be the EF. So I put that to give the possibility to save. We have to create first of all one leg, but I can remove it from now. I will remove it. I delete. Oops. So Balmo will be the first one. It's IF. Okay. After Balmo, we remember it is Gouvy, and I say TF Gouvy. And after Gouvy, we have the RF leg going to FF31 left, RF here, but I give the name of the waypoint center. The waypoint center is CTR2 RF. After that, we will have to tell him other thing we will do after. And after our point of the FAF, we are going to the runway. 31 left runway. By pressing this button, we automatically have the good altitude. The path angle I see is not the good one because at Marseille the path angle is 4 degrees, not 3. That's not a problem. We will adjust this after. So from now we are quite okay. The only thing that here we need to give it the left turn to go to our position. But for now, I'm sure it's working. We save it and we can press it to see. And there it is. So we have Balmo, Gouvy, a perfect RF leg, our FAF, and now the runway. From here now, we have to put a vertical trajectory. I give an example only. We can start from 3,000 feet at Balmo, and then Gouvy will be at or above 2005. Validate. And the FAF can be, I think it would be good to be at or above 1,300. And for here, we know that it's 111 feet because of the threshold crossing height and the threshold altitude. I can say that, and I press on 3 dimension and I ask it to be on Google Earth. This can help me to see if it will work around the terrain. So we see that we avoid the no, we don't see. I thought it was possible. This city of the Rove, we avoid it. It's okay. And we are going down from Gouvy, then 31 left, and then after that landing. We will see the rest after of the procedure in another video.